Okay, so to do cosecant of 17 pi over 6, first, just to be able to do it, you've got to figure out where it's at. And so when I think of 17 pi over 6, keep in mind, just here's some things I know. I know if I do 2 pi, that's the entire way around the unit circle. That's the equivalent of 12 pi over 6. And I'm thinking of it like that because I see that this one is over 6. So I know that 17 pi over 6 is the same as 12 pi over 6 plus 5 pi over 6. So when I am picturing and I'm trying to figure out where 17 pi over 6 is, I can picture and I'm like, all right, I go 2 pi, which means all the way around my unit circle, and then I go a further 5 pi over 6, which keep in mind, that's not quite a whole pi because 6 pi over 6 would be a whole pi. So I know it's somewhere right over here, approximately, would be where 5 pi over 6 is, and that's at the same place as 17 pi over 6. So I'm going to think of this as the same as the cosecant of 5 pi over 6. Now I know that cosecant is 1 over sine. So if I can figure out what the sine of 5 pi over 6 is, then I can totally figure out what the cosecant of 5 pi over 6 is. All right, and so 5 pi over 6, I'm going to go look on my unit circle, and I'm looking for a sine. So we're going to go to our unit circle. So let me make this bigger. 5 pi over 6 is right here. And the point that goes with 5 pi over 6 is this. And sine is the y value. So 1/2 is the sine of 5 pi over 6. So where I'm going to put that is I'm going to go back over here, and I know that sine of 5 pi over 6 is 1/2. And if I want to do 1 over 1/2, to get this fraction off the bottom, I'm going to multiply by the reciprocal. So what ends up being is 1 times 2 over 1. That's just 2. So the cosecant that we started out with of 17 pi over 6 is just 2. So when you see these and they're larger, you're going to figure out where exactly it's at on the unit circle, and then that's the one you're going to look up. So if we go look just real quick over here at some of these two, let's do some quick practice real quick. So on the self-assessment, so the negative 7 pi over 9, all right, if we're looking at where that's at, switch colors real quick here. So if I'm going negative, then I'm going this way. 7 pi over 9 is not all the way to pi. Keep in mind that negative pi over 9 would be like negative pi. So I think this is about negative 7 pi over 9. And so if I want to find out how much this is right here, this is the reference angle, then if I were to go from a full pi, which is 9 pi over 9, and take away 7 pi over 9, then what I'd be left with is 2 pi over 9, which would be our reference angle. Remember, your reference angle is created by the terminal side and the x-axis. That's how you find it. So I left both of these in radians because I wanted to show you, like, I think radians are harder to work with and degrees are easier. So if I want to find 15 pi over 4, all right, well, first of all, if I have 8 pi over 4, that's the same as 2 pi. And then I'm going to go another 7 pi over 4 around. So right here from the beginning, if I go around one time, that's 2 pi. And then I need to go another 7 pi over 4. So that's almost 2 pi over. I just am going around again. So that's about 7 pi over 4. All right, so if I want to find how much I am short right here, this is my reference angle because it's created by my terminal side and the x-axis. That's where the reference angle exists, between the terminal side and the x-axis. So if I know, I'm not going to think about this as 15 pi over 4. I'm going to think about it as it's in the same place as 7 pi over 4. So if I take, and it's in the fourth quadrant, and the formula for the fourth quadrant said that we're going to take 2 pi, and we're going to subtract 7 pi over 4. All right, 2 pi is the same as 8 pi over 4. And when I subtract 7 pi over 4, I'm just left with 1 pi over 4. So the reference angle is just pi over 4. And you just essentially locate where it's at and then follow the formula based on what quadrant it's in. So the formulas that we had back here, tell you what to do in each quadrant to find the reference angle in both degrees and in radians. So if you can draw the angle and figure out which quadrant it is, then you can figure out the reference angle. Okay, and so if we want to evaluate this without using technology, when it says this, it means use your unit circle. So if I want to find the sine of 315 degrees, all right, if it's on my unit circle, honestly, it's really quick and easy. I just go to my unit circle, I look for 315 degrees. So that is right here on my unit circle. And remember that cosine is the x value, sine is the y value. So right here, the y value is negative square root of 2 over 2. So if I want sine, literally sine is just the y value, which was negative square root of 2 over 2. So whenever it says without using technology, it means it's going to be on your unit circle. All right, so first on this one, 11 pi over 4. All right, let's think about where that is. So keep in mind, that's the same as 8 pi over 4 plus another 3 pi over 4. And the reason why I wrote that like this is because 8 pi over 4 is like 2 pi. So if you think about if you start on your unit circle and you go a full circle around, that's 2 pi. And then I go another 3 pi over 4. So that's to right here. So when I want to find the secant of 11 pi over 4, it is the same as the secant of 3 pi over 4. And the reason I rewrite it is because 11 pi over 4 is not on my unit circle, 3 pi over 4 is. So I figured out where it was. I basically ignored the first circle it did around. So I ignored the 8 pi over 4 and I found what was left, because then I can look this up on my unit circle. Now keep in mind that secant is the same as 1 over cosine. So I'm going to figure out what the cosine of 3 pi over 4 is, and I'm going to write it on the bottom of this fraction. So I go to my unit circle and I look. And so if I go to 3 pi over 4, it's right here. It goes with this point. The x value is cosine, so negative square root of 2 over 2. All right, so negative square root of 2 over 2 is what we need to fill in on the bottom here. That's right here. Now, the hardest part about this is you now have a fraction and a fraction. So what you have to do is you multiply by the reciprocal. All right, so on the bottom, it just cancels out. On the top, you're left with 1 times 2 over negative square root of 2. That negative can go on the bottom, but honestly, you guys, I think it's easier to put it up with the 2. It doesn't matter where it goes. So if you just put it up with the 2, it's easier. Now, this would be our answer, but you can't have a square root on the denominator. So we rationalize the denominator. We times by the square root of 2 over 2, which on the bottom makes square root of 4. The square root of 4 is 2. Now these two cancel out, but that leaves the negative. So this is our answer. And that just takes a little bit of practice, but you'll do it so many times with square root of 2 over 2 that you'll get really good at it. All right, so really fast, the formula here you're going to use on your homework. I will give it to you when we do a test. You just need to know how to use it. So D is the horizontal distance that an object is traveled when it is launched at an angle theta. So theta is the angle. The initial speed is v, and it's measured in feet per second, and this is the formula you use. So here's our angle right here of 50. Our initial speed is 105. So if we want to go ahead and fill in what we know 105 goes in for v, and then sine of 2 times 50. All right, and so because I am in degrees, I know that I must be in degree mode in my calculator. So just make sure when you press mode on your graphing calculator that it is in degree mode. And I type this in my graphing calculator and I get 339 feet is how far it travels. So you'll need to use this formula on your homework today, but when we do it on a test, I will provide the formula. You just need to know how to use it and to make sure that you're in the right mode.